In the previous section, we have learned about two ways to calculate the interest. So the first way is called the simple interest. So we have simple interest. And the second way is called compound interest. Right? And we also learned that to calculate compound interest, we need to know what is conversion period. And also after that, we learn about this effective interest rate. Okay, so in this section, we are going to learn about the annuity and some others product of finance. Right, we are going to further our study in the applications of mathematics in finance. Right, the first product, financial product that we are going to learn is called the ordinary annuity. Okay, what is annuity? Annuity is actually a sequence of payment made at regular time interval. Okay, so you actually pay some money, right, at a regular time interval. For example, every month, right, you pay certain money, and then at the end of the time interval, so you will get one lump sum money from the financial institute. Now the EPF, I believe you heard about this EPF before, right? Or we say the KWSP. Right, now this is one type of annuity. Okay, now the annuity may be paid at the end of the payment period, right? We call that an ordinary annuity. Or at the beginning of payment period, we call that a due annuity. Right, in our discussion here, we are going to focus on the ordinary annuity. So an annuity in which the payments are made at the end of each payment period is called the ordinary annuity. Okay, so we are going to focus on the ordinary annuity. Okay, so we take one example to know better about this annuity. Right, this is the formula we are going to learn. All right, the S is the future value of annuity, right? Remember future value? Future value, it means that the money we are going to get in the future. All right. So what is the R? The R refers to the regular payment, which is the payment that we pay at time interval. Okay. And the I is the interest rate, right, per conversion period, as we learned before. And the N is the number of compounding, right? So how many times the financial institution pay us the interest? All right, so minus 1 over I. Now let's take a look on the example here. Now suppose you decided to deposit $100 every 6 months into an account that pays 6% compounded semi-annually over 3 years. How much money will be in the account after the last deposit is made? All right, so now you pay $100 every 6 months and into the account, right? So imagine this is the account. So you pay, right, $100 every 6 months. Okay. Now, so this $100 is called the regular payment because we pay this amount of money every 6 months. So we pay it regularly. All right. So the bank is paying 6%. So beside this $100 payment, now another type of income from this account will be, right? So the bank is paying the interest, right? 6% per year, right? And it's compounded semi-annually. Okay, now semi-annually, what is the M? Okay, now take note, the M is not 6, right? The M is 2. right? Because every year, all right, the interest is compounded 2 times a year. Okay, 2 times a year for every 6 months, semi-annually. All right, so please take note of this, right? So now from here, we actually know that this account this account has 2 types of income. The first type of income is the regular payment. Every 6 months, there will be $100 paid into this account. And also, every 6 months, there will be the interest, right? The interest, 6% per year made into this account. Now, and this payment and the interest, right, compounded for 3 years. So we want to know after 3 years, how much money do we have in the account? All right. So now, according to the calculation, if we are using the formula, so we have the R is $100. Now the I, what is the I? The I is the interest rate per conversion period. So it means that each time when the bank pay the interest, what is the interest rate they use? So we know it's actually 1 year, 0 to 12 months, 1 year, 6%. So however, the bank will calculate the interest every half a year, semi-annually, every half a year. Therefore, for 6 months, every 6 months, the bank will pay 6% divided by 2, which is actually 3%. All right, so every 6 months, the bank will pay 3%. Another 6 months, the bank will pay 3%. So 1 year, 6%. Therefore, we are going to use a 6%, 0.06 divided by 2, and we get 0.03. It refers to 3% every time when the bank calculates the interest. Okay, so this is the interest rate per conversion period. All right, so now this N here, all right, so refer to how many times the bank calculates the interest. So we know that each year the bank calculate 2 times. All right, for each year. And for how many years? For 3 years. So total, the bank is going to calculate 6 times. The bank is going to pay 6 times interest to the account. Therefore, this will be 6. Okay, so minus 1 over the I, right, which is 0.03. And using the calculator, we will get the future value is $646.84. Okay, now what does that mean? It means that, all right, every 6 months, every half a year, you pay $100 for 3 years, right? 3 years, how many months? 3 years, how many times? 3 years, each year 2 times, right? 3 years, each year 2 times. Therefore, you are going to pay $600. $600 is your money, the money you pay, all right, every 6 months into the account. So after 3 years, you have $600. So from here, we know that the $46.84, this amount of money is actually interest generated by the money inside the account. Okay, so let's see what happened. Okay, now, so this is the payment, 6 payments, right? You pay into the account, right? So now the first 6 months, the 1 year means that the first 6 months, right? So we have 6 months here. The first 6 months you pay $100. So this $100 will actually generate 5 times of interest. 1, 2, 3, 4, 5. 5 times of interest. So we have 1.03. Okay, so we have $100, 1 plus 3% interest. Now the 1 here is actually 100. Now if we multiply, we have 100, but plus 3% of hundreds, right? 3% of hundreds. So this 3% of hundreds is the interest. Okay, so this is the interest, and 1 here is actually the $100. So we have 1.03, alright, so this is 1.03. So we have 1.03 generate 5 times interest. Okay, so this is for the first payment here. So similarly, now the second half year, right, which is 1 year, right, second half of the year, at the end of the second half of the year, we will pay another $100 again. So this $100 will generate 4 times of interest. You see, 1, 2, 3, 4, 4 times of interest. Therefore, it will be $100. Alright, so generate 4 times of interest. So it will be 1.03 to the power of 4. Alright, and then, right, another 6 months, you have another $100. And for this $100, it generates 3 times of interest. 1, 2, 3. Therefore, you have 1.03 to the power of 3, 3 times of interest. Alright, so now we can actually do this repeatedly, and for the last last payment, because it's at the end of the at the end of the 6 months, therefore the last 100, it does not have any interest generated. Okay, now so from here, when we actually calculate this and we sum all this, we have 600, 1, 2, 3, 4, 5, 6, 600, and the interest here will actually give us $46.84. Okay, so this is what actually happened. Okay, now so however, the slide here, this slide here actually is to explain the process. So when you do the calculation, you do not have to do this, right? You can actually use the calculation, use the formula to perform the calculation and to give the answer directly. Okay, so what you need to focus is the formula and the calculation and then the answer. Alright, so this is for explanation only. Okay, now so after we learn about the future value of annuity, right, the money we are going to get, right, so the next concept will be the present value of annuity. Now, what is the present value of annuity? Now, the present value, it means that the value you are going to invest now, right, in order to get the regular payment. Alright, so let's take a look on the example here to understand this better. Now, how much should you deposit in an account paying 6% compounded semi-annually in order to be able to withdraw $100 every 6 months for the next 3 years? Alright, now students, can you see what is the difference, right, between this example and the previous example? Okay, now the previous example, we are talking about future value. So what happened is that every time, at every interval of time, you pay the certain value. Okay, you pay a regular payment into the account, right? So you can see here, I draw this arrow. It shows that you pay the payment into the account, all right, and the account generate the interest. Okay, so this is important. The account will generate the interest, right? So this is the future value. Now for this present value, we are talking about you pay one payment into this account, and every month you withdraw the money. So you can see the arrow here is actually taking out $100 every 6 months, but the account will generate the interest itself. Okay, so this is what we call the present value. You put in the value, right, total amount, and you take out the value take out a certain value regularly. All right, so future value, we pay the money regularly. Present value, we withdraw the money regularly. Okay, so for present value, right, we are going to use this formula. Okay, now please take note that the formula is different from the formula we have for future value. Okay, so for future value, we have this formula. Okay, this formula is future value, and the present value is something like this. They are similar, but they are actually different. All right, so let's see what happened. Now the R is the regular payment, but this regular payment is actually the payment withdrawn, all right, taken out. Okay, now, and then the I is the interest rate per conversion period, so it will still be the R over M. Okay, so what is the M? The M is again the conversion period, so semi-annually. What does that mean? Semi-annually means that every half a year. So every half a year you take out $100, and so 1 year it will be 2 times. All right, so therefore, right, it will be 6%, right, divided by 2 again is 3%. So the bank will actually pay the interest at a rate of 3% every 6 months. Okay. So what is the N then? The N is number of compounding period. So how many times the bank will actually pay the interest? It will be 2 times a year times 3 years. So altogether 6 times. Okay, so by substitute all this into the formula, first we have the R is hundreds. Okay, the R is hundreds. So R hundreds. The I is 0.03, so substitute here 0.03. The N is 6, so we have 6 here, so it makes the whole thing negative 6 divided by the I, still, right, again we take 0.03 here. So by completing this calculation using the calculator, we will get the present value is $541.72. Okay, so now I just want you to take note that now you can see here, all right, every 6 months, all right, we withdraw $100. So $100 we withdraw every 6 months for 3 years. All right, so for 3 years now, so each year how many times? 2 times, right? Because every 6 months. All right, so withdraw $100, 3 years, each year 2 times. So the total money withdrawn is $600. Okay, so we actually take out $600 from the account, but you only need to deposit $541.72 into the account at the beginning of the 3 years. All right, so we call that, right, the present value. All right, so in the beginning you just need to deposit this amount of money into the account. So you take out, at the end you take out 600. Therefore there will be 58.27. Right, $58.27. This is the interest generated by the account. Okay, so again, let's look at this timeline, right, to understand it better. Okay, so now first, right, you pay 541.72 cents. All right, 72 cents. You pay this amount of money in the account. All right, in the account. So after the first 6 months, you take out $100. So this $100, all right, it will actually generate one time of interest. Okay, one time of interest. All right, so after that, all right, another 6 months, you take out another $100. So this $100 will actually generate 2 times of interest. All right, and after another 6 months, the third hundreds will actually generate 3 times of interest. So until the last hundreds, this 100 will actually generate 6 times of interest. Therefore, right, the total amount you need to actually put, right, is 541.72 only. Okay, so this is how we actually calculate the present value by using this formula.